Welcome to the Bentley Systems training course where you are going to learn how to design post-tension concrete slabs and RAM concept using generated tendon workflow. In this video, we are going to be focusing on modeling profile polylines. Profiles for distributed and banded tendons are determined by creating profile polylines on the tendon parameters layer. Tendon half spans are created wherever a generated tendon intersects a profile polyline. Now, profile polylines can be created using one of two methods. You can either create them manually using the Profile Polyline tool, or you can generate, span, and support polylines for the entire floor in one direction using a Generate Profile Polylines tool. Now, you're going to note that the Generate Profile Polylines tool will automatically generate support polylines that coordinate with the location of the span segments modeled on the opposite design spans plan layers. It is important that the design spans and strips are generated prior to generating your profile polylines. After you create your distributed tendon quadrilaterals and your tendon voids, you are now ready to generate your profile polylines. The Generate Profile Polylines command is used to automatically generate profile polylines using span segments that have already been defined in the design strip layer. To automatically generate your profile polylines, you're going to go up to your standard toolbar and then click on the Generate Profile Polylines icon. Here you can specify the polylines to generate, and we're still working on the latitude direction. And then we can tell the program if we want to generate your support polylines, which is basically your elevation at end 1 or your high point, and your span polylines, which is your elevation at point 2 or your low point of your tendon. We're going to enter an elevation reference information and the elevation of the slab. Now we do have several different ways that we can enter our elevation and the elevation reference. For this particular model, we're going to enter an elevation of 1.25 inches for the profile and your span polylines, and then we're going to specify our elevation reference. If we select the absolute quantity, this would basically mean the elevation would be referenced to the 0 datum. We could enter the above soffit information, which means the elevation will be measured from the soffit to the elevation of the CGS of the tendon. We can select above surface, where the elevation is measured from the surface elevation to the CGS of the tendon, and this value is almost always negative. We can enter some top cover information, which means that the elevation will be measured from the surface elevation to the CGS of the tendon. Now this value will always almost be positive. And lastly, we can enter your bottom cover information. This would be where the elevation is measured from the soffit elevation to the CGS of the tendon, and it's usually always a positive number. We're going to enter our elevation reference from the top cover and the bottom cover for our support and span polylines respectively. Once we are done, we'll go ahead and click OK, and then the program will go ahead and create your profile polylines for you. RAM Concept has now generated all of the support and span polylines to generate the full post-tension layout for the latitude direction. You're going to notice that the support profile polylines are going to be displayed graphically as solid lines, while the span polylines are displayed as dashed lines. Now, even though we asked RAM Concept to generate our polylines for us, we still need to review the polyline layout to see if it's appropriate. The first thing we're going to do is we're going to take a look at our support polylines that are adjacent to the edge of slab along grid lines 1 and 9. Automatically, when the post-tension layout is created, whenever a distributed polyline intersects a slab edge, it's going to automatically terminate at the mid-depth of the slab. Now what we can see is we have some support polylines just adjacent to the edge of slab with a cover of 1.25 inches. Then if you were to bend the tendon up to the mid-depth of the slab, you would most likely be violating the minimum tendon radius requirement. To adjust this, we're going to go ahead and delete the support polylines along grid lines 1 and 9, basically wherever it's exiting the slab. To do that, we're going to use our selection tool, and we're going to select all of the support polylines that are running just parallel to the edge of slab. Once you have them selected, you can go ahead and click Delete on your keyboard, and now we know that we're not going to have a minimum radius issue at those locations. In addition to that, if I zoomed in at a few certain particular areas, especially the areas that might be skewed on your plan, what you're going to notice is that some of these span polylines might be overlapping, while some of them might not be quite reaching the intersection that you want it to. Here, for example, if I hold down my Shift key again, I'm going to select these span polylines along grid line 2. And here we can say they don't quite meet here and they're overlapping here. Now, whenever a distributed polyline intersects one of these, either the support or span polylines, what's going to happen is it's going to take on that profile point. If you have one that's overlapping here, you may get two support points or two span points that are very close together. Here, you might completely miss that span point. So what we can do is we can use any of our manipulation tools to move, stretch, rotate, or mirror our span polylines. For this exercise, I have this one selected. So I'm going to go ahead and double click on this polyline. And what I'm going to do is I'm going to move it back to its intersection point. Now, it might be best to zoom in on your screen in order to get a closer view. And again, you can use any of your snap tools in order to achieve what you want. I have this polyline selected, and I'm going to go ahead and just use my Move tool. And I'm going to move the end from there to the intersection point, which is basically going to move it down. Then I'm going to keep adjusting as necessary. So I'm going to select this polyline now, and here I can use my stretch tool. And I'm going to stretch it forward. And then I'm going to also stretch them back to their intersection points. Now if I zoom out, I can see that that polyline is exactly the way I want it. Now if I'm still examining my plan, I can also see that I have some span polylines along grid line 8 that aren't exactly the way I want them. But this model is symmetrical, and I already went through the process of fixing the span polylines along grid line 2. So what I'm going to do now is I'm just going to grab all of my span polylines along grid line 8 and delete them. And what I'll do is I'll copy the ones from the left-hand side of the plan over. So I'm going to select the polylines I want to copy. We're going to mirror it about grid line 5. And so I'm going to click on my mirror command. Now we want to make a copy, so I'm going to make sure I hold down my Shift key. And I'm going to click at one point along grid line 5 and then another point. And then you can see that's a very easy way to achieve the geometry that I'm looking for. We will now navigate our way to the longitude tendon parameters standard plan, where we're going to use more of a manual approach for creating our tendon polylines. Now this approach is quite suitable for this plan since we do have a mixture of just typical concrete slab as well as your deeper concrete beams. Now to manually create your support polylines, which is where you'd want to start, you're going to go over to your layer specific tools and double click on your profile polyline icon. This will allow you to specify the properties of the location that you want your profile polyline to be at. We are going to be creating some support polylines, and we're going to enter them according to the top cover requirements. And we're going to start by specifying an elevation. I'm going to start with my typical slab around the edge of slab location. I'm going to start by entering a top cover of 6 inches, and you can use this tool to either generate support or span polylines. This will allow you the greatest control over specifying the location of your tendons. Once we're done, we'll go ahead and click OK. And then you can start by modeling these polylines. I'm going to click on grid intersection E1 and then E3, and then I'm going to right click and say enter. Now this longitude tendon and this longitude tendon will both exit the slab at 6 inches, which is exactly mid-depth of the slab. I'm going to repeat this process everywhere that this would be applicable for. And again, anytime a tendon intersects a polyline, it will keep that point. And we will continue this process for anywhere we want to draw a support polyline. Now, if you would like to change the location of your polyline, you're going to double click to redefine the properties. Here I'm going to change the properties to 12 inches, which would be more appropriate for our concrete beams along grid lines 4, 5, and 6. And lastly, we're going to redefine this again and do our support polylines that'll be more for your field of your slab. Here I'm going to enter 1.25 inches. Again, I'm going to use top cover. Now, after you model your support polylines, you are able to edit the properties just like you would any other object in RAM Concept. So say, for example, I meant to draw these polylines at a top cover of 5 inches. I can just select them, right-click, and say Selection Properties, and I can change their top cover requirements. If you also noticed, I can also change it from a support to a span polyline. Now that we have finished creating our support polylines, we could create our span polylines one of two methods. We could either, again, use this tool and select span instead of support, or we can use our support polylines to have the program automatically generate our span polylines, which is what we'll go ahead and do for this exercise. To do this, we must first tell the program which support polylines we want considered in this operation. So I'm going to use my selection cursor and draw a fence around the entire plan. I can use my filter to go ahead and just select my profile polylines. And now we have all of them selected. Now over in my layer specific tool, I'm now going to click on the generate span polylines for selected support polylines. If I select this, I can go ahead and select their properties, 1.25 inches from the bottom cover. Span ratio at 0.5, which basically means it's going to locate a span polyline halfway between two different support polylines. And then we'll go ahead and click OK. Now at this point, the program has generated all of the span polylines that we're going to need. Now again, we can go ahead and use any of our manipulation tools to either move, stretch, or edit any of our span polylines until the plan is exactly the way we want it.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.